his 15th distinguished lecture being organized by INA Bhubaneswar chapter, SOA University, and IMMT Bhubaneswar. And this possibly this last sector that we have before the so-called Amrit Mahotsav of Indian independence. So next one definitely will have after 15th August. And I'm really very happy today. The other day, we listened to beautiful lecture by Professor Farooq Mistry. And today, his better half, Professor Janet Allen, she is actually going to speak to us. And as you know, it is exactly Farooq's word, the best job on the earth is the life of a professor, and it becomes better if the spouse also happens to be the professor. And this is what has actually happened here.
I agree.
Briefly, of course, the biodata of Professor Allen has been already sent to you. But briefly speaking, she earned her degrees from University of California, Berkeley, PhD in biophysics, and that too in 1973. And she had from the MIT, Cambridge, the MA and BS in life science in 67. So far as her important appointment goes, she is currently John and Mary Moore Chair of Engineering and Professor of Industrial Engineering in the University of Oklahoma from August 2009 onwards. Also, he is appointed as the M3 in Aerospace and Mechanical Engineering. In Mechanical Engineering, in February 2010. Therefore, Professor Allen is eligible to mentor PhD students in both industrial and systems engineering and mechanical engineering. Prior to that, she was Senior Research Science Associate Professor, and Professor of Emeritus of George W. Woodruff School of Mechanical Engineering in Georgia Institute of Technology, another great institute. She was also Director of Research and President, Janko Research Inc., and a postdoctoral fellow and instructor division of arthrosis and Lipotin Research, Baylor College of Medicine, Houston. And like this, she is actually also she was also in the National Institute of Postdoctoral Fellows in Center for University of Southern California, Los Angeles. So far as his honor list goes, she's in the Norman Campus Wide Research and Creative Activity Award she got in 2021, ASME Rath Joel Spira Outstanding Design Educator Award in 2020, ASME Journal of Mechanical Design Reviewer and Distinction Award in 2020, Professor Emeritus in the George W. Woodruff School of Mechanical Engineering in Georgia Tech, John and Mary Moore Chair of Engineering at the University of Oklahoma, Fellow of the American Society of Mechanical Engineering. Then she is R.E. Fulton Best Paper Award winner in Engineering Information Management Committee of ASME Computer and Information Engineering. She is also a senior member of American Institute of Aeronautics and Astronautics, a fellow of the American Heart Association, and also the fellow, honorary member of Pi Tau Sigma National Mechanical Engineering Society, National Institute of Health, pre-doctoral and postdoctoral fellowship she has also got. And what is interesting, starting actually with the biophysics background and life science background, she has turned herself to an engineer, to a designer, and an outstanding professor in engineering, both mechanical as well as industrial engineering and aerospace engineering. So a really big journey over the period. Now, Farooq actually talked about the Make in India mantra in these next 25 years in his last lecture that he gave on June 17 to INA Bhubaneswar chapter in this forum. Now, in this context, now Janet actually will be speaking on design and make in India is make in India, and that it is foundational to the, anyway, let me just read it. In this context of design and make in India mantra, she plans to highlight some of the opportunities embedded in the Industry 4.0 construct that is associated with manufacturing and introduce the Design Engineering 4.0, a new concept that complements the Industry 4.0 constant, foundational to sustaining design and make in India, a basic research. Now, accordingly, she will touch upon the state of government funding of basic research and how it could be directed to further design and make in India mantra. And one thing also I forgot to mention that both Farooq and Janet, they belong to Pune, and they have been actually consultant to Telco, doing actually a lot of work on the design side, along with Telco R&D at Pune. So here is a man, here is actually a couple. They are very much committed to India. They do a lot of work for India, and also both of them are great teachers. With these few things, now I would request our Professor P.K. Nanda, who is the Pro Vice Chancellor of SOA University, to speak something about SOA. Maybe some of the participants here, they may not be having aware of all these things, but I think this will be a good forum to say something about our course sponsor, that is SOA University. Professor Nanda, please.
Thank you, sir. Good evening, esteemed speaker, Professor Janet Allen. I think Madam Ma'am and Professor Janet Allen and Professor Farooq Mistry both mentored us for ABET accreditation. They visited our campus and also in the workshop they delivered lectures. Madam also, Professor Janet Allen also delivered lectures in particularly in our campus. And I think it is quite gratifying to have Professor Janet with us and share her beautiful experience and also the idea and thoughts with all of us. As about SOA University, I think I'll just briefly, I think, mention few points only that yes, SOA has started with a very humble beginning, and it has grown over the years to a huge university with 14,000 students and 1,300 faculty members, and with 1,200 research scholars. And we have been figuring in consistently in the top 25 bracket in the NIRF ranking right from the inception of the NRF ranking framework of Government of India in 2016 to 2022. And this year we figured in the university category as 16th rank, and even engineering, faculty of engineering is 27th, and faculty of medicine is 18th, and dental is 10th rank in the country, and faculty of law is in the 9th rank. So we figured in the NRF ranking. And also this year, our accreditation, National Assessment and Accreditation Council evaluated us with a AA+ grade. And our university is now visible in QS ranking. That is QS World University ranking. It is 800 to 1000 bracket. And THE World University ranking also it is 1000 to 1200 bracket. And in QS Asia we are 400 to 450 bracket. QS India we are diamond rating institute university. So as far the university research is concerned, we have established 16 research centers. 2 more research centers are on the anvil. One is biomedical engineering and its applications. I think this is one we'll add, and a smart agriculture research center also will add. And we are now focusing on interdisciplinary research, and also we are thinking of collaborating with different institutes of repute. And in between, you have signed MOU with IIT Guwahati, and also IMMT. We have other institutes who are going for the signing MOU with IIT Kharagpur as well. And our faculty members are proactively engaged with research. As a result, we have a visible funding, and the first interdisciplinary research funding we got from the DBT Builder with tune of 5.47 crores, which is the single largest project we have from our university faculty who have joined together from dental science, medical science, pharmacy, and biotechnology. I think our university is now focusing on to be a research intensive university and jointly work with other researchers, top-notch researchers in the country as well as abroad. We have signed MOU with other university as well, initiated some work, and I believe in future we'll definitely be stronger in research. And in fact, the inspiration of Prof. Farooq Mistry, who is in our advisory board, always inspires us to progress and to do well and to be visible in the global map. With your all good wishes, I believe Professor Janet, Madam, and Professor Farooq Mistry will be definitely visible in the global map in future. Thank you. Thank you very much. Once again, welcome to this forum and eager to listen to your lecture. Thank you.
So thank you very much. I'm indeed honored to be here. Thank you for the invitation. And it's good to see some of my old friends here. So with that, I'll move on to the talk. And as I'm sorry, can you see my presentation?
So,
Does it come?
Farooq has to share the screen.
No, it is not come.
Let them share the screen. Yeah.
Is it there?
Yeah,
Yes.
Good.
absolutely. It is fine.
Yes.
Absolutely.
Yes.
As Damodar mentioned, I'm going to be talking about from make in India to design and make in India. And so Farooq, no, it's not moving. There it is, sorry.
Yeah.
So he also told you about the abstract a little bit. So let me just emphasize that in the context of design and make in India, I want to talk about some of the opportunities that India has in front of it and introduce the idea of design engineering 4.0 to complement industry 4.0, which some of you have heard about, but I'll talk a little bit about more later. I also want to think about how foundational to this construct design and manufacturing are with basic research. And I will touch upon the state of government funding in India and how it could be directed to further the design and make in India approach. Starting off in India, Industry 4.0 has evolved, and in the world, it has started with Industry 1.0, which was mass production for global markets. You can think about that basically as mechanical production equipment powered by steam and water, and humans were using machines for mass production. So that was what was happening in the 18th century. In the 19th century, we moved toward Industry 2.0, mass production assembly lines required. And in that case, we had one task, one person, and we were moving towards specialization of jobs. In the 20th century, we moved to Industry 3.0, and we had automated production using IT and electronics. And so that was efficient manufacturing, and we reduced manpower requirements for production. Now today, we are moving toward cyber-physical systems where we have connected machines and everything works together. Intelligent production incorporated with IoT, Internet of Things, cloud technology, and big data. So that's what is going on in general in global industry and Industry 4.0. So what we're thinking about is integration of entire businesses digitally. And this is requiring interconnected technologies. All sorts of things come into it: artificial intelligence, machine learning, analytics, and so forth. But we also have multiple stakeholders: engineers, users, manufacturers. Many people are involved in making the products happen now. And we want to increase efficiency. Now, there are some consequences to increasing efficiency. Here with Industry 4.0, it's mainly a consideration of manufacturing. We are centralizing the decision-making process. So fewer people are actually using their innovation and creativity. We have a centralized group of people. We are reducing the labor requirements, but the workers that we have may need to have higher education. And so that also will displace some people from their jobs. And so you need to think about what the people will do if they are displaced from their job. So we'll also need substantial investment, and it will be ongoing investment that is needed to do this, especially for digitization. A consequences of this is it may reduce competition. So high investment increases the barriers needed to entry in markets. So this is the kind of thing that is going on. So what is making this happen? So there are drivers of Industry 4.0, servitization, that is managing machines as a service and manufacturing as a service, indeed anything as a service. We're thinking about integrated customer and employee experiences, so we're moving closer and closer to doing things together. We have operational flexibility and agility, and we are thinking about more smart products produced more rapidly. We're thinking about robotic manufacture, and we're thinking about convergence of production systems. So we're thinking about business systems also being incorporated in this.
No thinking about.
So what we're thinking about is globally manufacturing is embracing the paradigm of Industry 4.0. So what should India be doing? Should India also follow suit? And some gentlemen from NITI Aayog have recommended that India also work toward adopting Industry 4.0. So because India has data, lots of data available at affordable prices, we've got technology and innovation access in a strong point. And India has a vast domestic market. Now, this vast domestic market also has to have disposable income to spend, but there is a vast potential domestic market. They recommend incentivizing investments, enhancing human capital, increasing institutional capacity, and providing a social security net. But most importantly, they recommend investing in R&D. They say it's critical in allowing businesses to stay ahead of the curve in an ever-changing world. So this is a suggestion that India also begin to follow suit in adopting Industry 4.0. India does have advantages. You have the digital know-how to accomplish business integration, and you have unprecedented connectivity. So on the other hand, there are some challenges that India has, and I think we should think about that a little bit. Many manufacturing enterprises will not benefit from Industry 4.0. Basic manufacturing, for instance, may not benefit from Industry 4.0, but there are some sectors and some places that Industry 4.0 could be very useful, perhaps in the automotive end of things or steel industries. But it does mean loss of jobs. India has relatively inexpensive labor, so returns on expenditures will be less than in countries with higher labor costs. There's also a need to educate those that are being displaced. So here's a general consumers of Industry 4.0, and I got this from a NASCOM report. This is written in February 2022, but some of the data in it is rather old. So they are talking about who the leaders of Industry 4.0, the directors of industry, disruptors of Industry 4.0, and emerging consumers. And in India, you can see here is more or less at the end here. So the percentage of global manufacturing share, 2.5%, manufacturing to national GDP output, so say 17% of manufacturing to national GDP. Tech spending is this, 11.7 billion. And this was in 2018. And digitalization ranking is low, and preparedness for future production is also not as high as it might be. So this is the situation, and you might begin to think about where the money in India is being spent. Again, this is from the same report from NASCOM. And you can see that in India, the spend distribution in 2021 is data analytics mainly, connectivity and technical issues, intelligent automation, and advanced digitalization technology. So these are the things that are going on in India, and this is where the money is being spent. Cloud services here, big data analytics is here. As we look at connectivity, IoT is very strong, being supported strongly. Robotic process automation is here, and that's also being fairly strongly supported. And advanced augmented virtual and mixed reality has a big portion of this amount of spending. So this is the kind of thing that is going on now in India. It does have some way to go to be competitive with what's going on in the rest of the world, but there is progress, and it's beginning to happen in India. So in addition to Industry 4.0, India can move up the value chain to design and manufacture. So what is design? Design is the process of devising a system, component, or process to meet desired needs. So focus here a little bit on the idea of designing a system. So all of the things that we are talking about with Industry 4.0 are systems, and they are expansions of systems, and they need to be designed too. And we believe that design is a decision-making process, and basic science and mathematics and engineering are converted to resources to meet a stated objective. So we believe that design is a process that involves technical issues, strong technical issues, but we're also moving to the point where there are going to be interfaces of the technical issues with political decisions, as well as with social decisions, and of course, environmental decisions too. So we can think about having both processes such as Industry 4.0 issues and products are possible to be designed. So what is design engineering 4.0? I've talked about Industry 4.0. That's what's going on in the top portion of this diagram. In the lower portion of the design of this diagram, you can see what is happening with design. So design engineering in Industry 1.0 is functionality, volume, craftsmanship, that sort of thing. It moved on later. We're talking about increasing the volume, increasing the speed of production, and decreasing the costs, standardizing things, interchangeability. That was with Industry 2.0. Industry 3.0 has with it design engineering 3.0. So we can think about we're having decreased volume and agility, cost and speed quality are still important. So there's some design automation occurring, but it's nothing like what is happening now with Industry 4.0. So we're thinking about mass customization, user experience personalization, smart and connected product ecosystems, not just single products, business models and value chains. So all of this has to be integrated into our production capabilities. Open innovation, co-creation, that's creation with others, for example, with customers, and data-driven decision-making. So these things, we believe, mean that Industry 4.0 and design engineering 4.0, manufacturing and design are becoming inextricably linked. So that's why I'll be talking about design engineering 4.0 in the rest of this discussion. So when we're thinking about merging design and manufacturing, design engineering 4.0, you can think about a situation like this, where we've got design engineering here, but we have all sorts of different things feeding into it. For example, human input. People are using the equipment, the customers are human. What are we doing for them? Businesses, of course, commerce is important. We're thinking about cybernetics, the computing sphere, and we're thinking about systems. So when we think about all of these things together, they spawn many, many different opportunities. Between human and business, we would be thinking about the Internet of People. Between business and cybernetics, strategic engineering, design and strategic engineering. Here, system and cybernetics, thinking about smart sensing, AI and technologies. And here, design of human cyber-physical systems, the Internet of Services, how things will work together. So together, all of these things are involved in design engineering. So we can think here about, again, Internet of People, Internet of Commerce, Internet of Services, and Internet of Things. Each of these things provides opportunities for basic research. So let's talk about each of these things for a few minutes. The Internet of People here, the drivers, and we're getting of this, the distinction between physical and digital selves of individuals will be blurred. So individuals will play a dual role. They'll be creators as well as consumers of technology. And we'll change in user preferences, so there'll be styles and preferences that change. And this will mean that things have to move more rapidly and change more rapidly. So the challenges would then be how you would foster an innovation ecosystem where consumers and designers play a creative role in shaping the future together. We're thinking about developing and maintaining a workforce that stays in tune with changing technological landscape. That means an educated workforce. Again, we have to be sure that the universities are able to help these folks keep up with the changes in the industry and design engineering 4.0. Internet of Commerce, of course, you need to make a profit, and this is important. So that's a driver. So the challenges are, how can you anticipate the ways that you can make money out of this situation? And also how network systems and ubiquitous design, data sharing, and cyber threats, we have to be sure that there are difficulties with security. And we have to ensure that that the security difficulties are dealt with properly. And this is particularly important when you're designing something. You don't really know what the security issues will be in it until it's actually in use. So this can be a problem with the Internet of Commerce. With the Internet of Things, here, should be over here, Internet of Things over here, network systems with IoTs will make data easily accessible throughout the life cycle. Need for design systems to collaborate and adapt to improve product process reliability, system agility, and sustainability. So the designers have a lot of responsibilities in this area. Information extracted from diverse data streams in real time, and this will aid decision making. So we're going to be having things that are going to be adjusted, need to be adjusted rapidly and flexibly. However, sometimes there will be designs that we want to experiment with that are new, that will be based on actual data. And can you design systems when you have partial or no data? What are you going to do about that? So when you have many different data streams coming in, you can get different information from these different streams, and perhaps they will not always be reliable, or they may contain conflicting information. What do you do about that? Also, can you obtain synthetic data using digital twins of the processes and use that in the design process? So all of these things are challenges for the Internet of Things. Again, research would be appropriate to find out about how these things were working. Internet of Services. You've got rapidly changing technologies, customer requirements and precedences. They're unpredictable disruptions and hard to manage. So also the customized products will change. So you'll want to have small lot sizes but also small costs. So these things will be needed. And you'll want to design systems that are resilient. In other words, when things change, they can be modified easily, sustainable, okay, and can adapt to changing conditions. When you can't necessarily anticipate what those conditions will be at the time of you're designing the object, which is, of course, appropriate, because when you think about the future, you won't be able to know specifically what's happening with your competition or with the other things in the market, how other kinds of technologies are taking over. We want to think about how to develop standards for interfacing and using physical entities and their digital twin across the entire ecosystem, from design to product realization. It's going to be important that these things all interact with each other so that we can have a effective system working together. So the easiest way to do that would be to standardize the interfaces between equipment, between machines. Also, we can think about what digital twins are doing and how these can be used when you're designing systems. And we'll want to use these digital twins when we are trying to respond rapidly to disruptions that affect production processes. So we need to be able to rapidly adjust what's going on and also affect the changes in it. So that was opportunities for the design of products. Let's think about something about the technology that will be involved. So these are strategic engineering, design engineering 4.0 opportunities. These are for basic research. So there'll be requirements in connectivity, virtualization, and interoperability, big data, and information transparency. We'll want to balance decentralization and modularity, interactivity, with centralization. So you need to think it needs to be developed on how this works out. Service orientation and networked resources. So going back here and thinking about connectivity and virtualization, interoperability, products will be smart and connected. We'll want end-to-end digital integration, and we'll want customization and personalization. All of these things are considered for basic research. We'll also still be thinking about ways of managing data-driven design, digital twins and intelligent design automation, extended supply chains and agile collaboration, and open innovation, co-creation, and crowdsourcing. So how will all of that work? And product servitization, anything as a service. So these things all contribute to the decentralization issues, modularization, and interactivity. So we're thinking, so here in service orientation, platformization for shared economy is going to be increasingly important also. So these are some technical areas that could be developed with basic research, should be developed with basic research. So what is needed now? I've talked a lot about research. So let's discuss. This has been recommended by the National Education Policy 2020, recommended for Industries 4.0 by some folks at NITI Aayog. And it is also going to be needed for Design Engineering 4.0. So we're going to be thinking about, we're going to be discussing research next, and particularly basic research. Now, Farooq talked about this in importance of research for higher education in India in his talk on June 17, 2022. So you will see that the way basic research is handled in the United States also produces many, many educated students, many educated people. And this, I believe, is an important way of going about producing both educated students, as well as research. So here I'll be focusing, of course, on research. Higher education and research funding go hand in hand, and they do in the United States, where the U.S. National Science Foundation funds research at colleges and universities, and students are educated together. So let's talk a little bit about what India is doing in research. First, I'd like to talk about the differences between basic, applied, and translation research. I'm particularly focused here on basic research, which is pure research or fundamental research, type of scientific research aimed at improving theories for better understanding and prediction of natural phenomena. So much of what has been done is applied and translational research, but these things are applied versions of basic research. So in other words, you need to have basic research in order to be able to do applied or translational research. Now, applied research uses the theories developed by basic research and developed technology or techniques, and these can be used to intervene after natural or other phenomena occurred. Translation research is aimed at translating or converting results in basic research, again, from basic research into things that directly benefit people. So this is translation research would be a subset of applied research. So you can think about this triad of ways of doing research. I believe that India needs to focus on basic research in order to fuel technological innovations of applied science. So that is where I'm coming from with this talk. But let's think about much of what India's current focus on the institutes of higher education are applied and translation research. So much of what India is doing at least in the Indian, in the education system, is applied and translation research. So we need to think about, it needs to be considered about to move some of this work toward basic research. So the first question is, how much research is going on in India? And this is what India is spending as a percentage of its gross domestic product on research. It's about 0.7%, which is, well, it's perhaps fairly low if you compare it with some other countries. But of course, this needs to balance between other priorities in India, and so that's what the population has decided. So this is where the data comes from. I believe that the percentage of research in India is the gross domestic product remains about the same. I don't think it's changed drastically since 2016. So we have comparing spending and results, counselors, scientific and industrial research versus IIT Bombay. So if you look at various amounts of spending on research from CSIR and IIT Bombay, you can see that CSIR, of course, spends a lot more than IIT Bombay. And you can see that the publications are also more, but perhaps not as much greater as the spending issues on research. Patents filed. IIT Bombay has more patents filed. Of course, they still have to, many of them have to be industrialized or used, but IIT Bombay has produced more funding. Publications, which is one measure of success in research, is CSIR has generally fewer than IIT Bombay. Patents filed for government funding. So this is patents filed for government funding. And graduates, students receiving education from IIT Bombay. So you can see that IIT Bombay perhaps is more efficient in producing research results, patents and publications, and also in producing students than the CSIR is. Okay. So this again is a little bit old data. I don't believe things have changed all that much since this data was developed. So in India, who does research? So you can see here, these are India, this is India here, China, Japan, Korea, United States. So the government is funding a great deal of the research in blue here. Businesses are funding some. Universities, a little bit is done here, and virtually nothing is done by private and nonprofit organizations. So India is dramatically different than what is happening in other places. In other places, you can see that business does a lot of research, and the universities do a considerable amount of research as well. So this is, again, a little bit old, but I believe that the general profile of what is going on is very, very, very similar today. So if you look at what is happening in India, you can think about, you can see how government is directing funding for R&D spending. And this is an example. This is the advisory committee for Semicon India. Got a lot of money, and it was established recently. Now, the idea is to establish a semiconductor industry in India. However, you can see who's doing it. How many of these people here that are on the committee actually know how to make semiconductors or design semiconductors? It is not clear that the politicians know how to do this. The financial people, well, finance is going to be helpful, but they already have quite a bit of money. How are they going to spend it? And most of the people that are associated with the computing industry have focused on data and software rather than on hardware and semiconductors. So the question is, how is this being funded, and how the structure of this way of spending money will be developed? So I believe that this can be a problem for India. I know it's the culture in India currently, but let me compare it with what I'm more familiar with, what's going on in the United States. So in the United States, we focus on merit-based research. This is one way. There are other ways of doing it, but this is what we do here. And again, I'm familiar with it. It is the U.S. National Science Foundation. And you can see the director of the U.S. National Science Foundation is here. So Indians are able to do these things. So what happens here, and you can follow the money trail in green, the Biden-Harris budget requests, these are the executives in our country, they recommend a budget request every year. They recommend it to Congress. Now, Congress has the purse strings. They're able to approve funding, and they adjust what they see as important and how it can be accomplished. So, for instance, the Biden-Harris budget might say that they feel that climate initiatives are important. Congress will approve some, and then the money is sent to NSF. Now, NSF has professional experts in various different fields, and these are the people that decide how the money will be spent. So when they say something about climate change is a problem, there will be a decision here about what is feasible from experts to say how much we should spend on assessing the situation with climate change, how much we should spend on various different mitigation efforts, how we should plan to reduce it, what are some ideas that are there. Now, these ideas that are assessed at NSF are gathered from experts, professors, faculty around the United States, and many, many ideas come in, proposals come in, and a few percent of those, the most meritorious ones, are funded. Money goes out. There is continual supervision as far as results. Every year you're asked what results you're getting, and if you are not producing appropriate results, then your funding is in peril. So this is the way merit-based research works in the United States. There is an annual budget here of $8.5 billion for the National Science Foundation. The National Science Foundation funds about 25% of federally supported basic research conducted by the colleges and universities in the United States. Other organizations such as the Department of Defense, the Department of Energy, other organizations also fund basic research. We also support the career development of researchers in various different ways. For example, I held a pre-doctoral and a postdoctoral fellowship for years ago, where the National Science Foundation and the National Institute of Health, which works similarly, funds the career development of researchers. Now, the important thing is that this is led by experts in their respective areas, not by politicians. So this man, the director here, has a strong track record in computer vision, and he was an academic administrator known for enhancing research at Arizona State University. So NSF is handled by people that are familiar with their disciplines. The proposals are evaluated by teams of different people that are, again, familiar with their disciplines, and it is not just a single decision that is made on each of these. Many people evaluate each of these proposals, and they're examined carefully, both for feasibility and for the merit of their work. So this is one way of doing things. There are other ways, but I believe that bringing more expertise into the process of selecting research projects would be important for India. So when we think about the Indian research structure, we believe that research is needed for successfully modernizing Indian design and manufacturing. So it's going to be essential. We saw that on slide 6. We think that we see now that most research funding goes to government laboratories, and that may not be the most efficient way of using the research dollars that India has. Indian universities are very capable, and especially the IITs, of course, are very capable of doing efficient research. They produce publications, which is one standard of measuring success, and patents as well. On the other hand, for many years, Indian universities have struggled to find faculty. And perhaps some of the government research laboratory employees could be shifted to faculty positions. I know can be difficult to accomplish, but that might be something that would be beneficial for India. As India moves to design and manufacture, an increasingly educated workforce will be needed, and the research performed by universities also produces an educated workforce. So moving some more research dollars toward universities, merit-based systems would be important. And so a merit-based approach to funding will also, I believe, yield a dividend for India, in which proposals are developed and evaluated by experts. So this is, I hope, the takeaway that you'll consider from this talk. So in closing, I'd like to think about I'd like to discuss something that Prime Minister Modi has said. The time for incremental change is long over. The current age is one that requires transformational change that comes only with drastic policy reform. So India may be able to make some changes and move strategically toward design and manufacture in India. So with that, have you questions or comments?
I invite questions.
Madam Bharani, would you like to coordinate questions?
Yes, sir. I would like to invite the questions from the audience.
Okay. I remember meeting you.
They can unmute them.
Hello, madam. This is A.K. Tripathi. I just want to know that you have been watching the developments in India, and you said between 16 and 17 and today, 5 years, there have been no substantial change in the data regarding the percentage of money of GDP what we spend on R&D. And you mentioned that it is very low and it has to be increased. You also suggested that the funding agencies and where they should focus. How do you think when we compare with US, India is definitely lagging behind in research and development by few years. So don't you think that whatever we do today in India has already been done in USA, and that is kind of a factor which is not able to make Indian scientists really come to the front and do something, because everything is available outside and in the product form, and it is easy to import a product and introduce rather than trying to manufacture it. That's what is confusing the production and manufacturing in India. Can you comment on this?
So I understand there are two areas that India is trying to do things on its own. For instance, sequencing the human genome and putting a man in the moon. These things have been done elsewhere. And I think that instead of trying to reinvent the wheel, India needs to work with other countries, partner with countries that have expertise and build on the existing ideas, not start all over again. So that many, as you know, many Indians are trained in the US, they are able to, they know what's going on. And so instead of starting, at the base, you can build on existing technology. So I think that's what needs to be done.
Okay.
Because, I mean, clearly there are a lot of smart people in India, and, they're able to do things. The space program is tremendous, what has been accomplished, but other people have done that. And so if you start at a different level, then you can move forward instead of starting at the bottom.
You mentioned about government funding. Government funding is one thing, and the corporate funding and funding by the private sector is another thing. I think that is much higher in USA than what is in India. Then how to trigger the public funding by the non-government sources? That is not picking up in India. It's very low.
I think this is an area that I am not so I'm not so knowledgeable in. I can tell you that, for instance, the National Science Foundation has a variety of programs. One of the ways is that they partner with industries, and they have industry people come to universities or the government laboratories and go back and forth. And for those programs, they are not only funded by the government, but also the industry has to put money in. They see an advantage because that they get some technology that they wouldn't have had otherwise, but they also have to pay something for it. So one way may be that, but again, this is not an area that I really can't tell you the best way to encourage business spending on research and development.
Okay, thank you.
Okay. Anybody else?
Thank you so much. I invite others to please unmute themselves and ask questions. Madhusudan sir, please.
Madam, I have got one observation. May not be the question.
Yes.
What is happening, as you have mentioned, that we have one of the advantages of this country is that we have got large internal market size. Possibly, that is actually one of the thing which is not really encouraging us to develop new products, improve our processes, and becoming competitive worldwide. And that is possibly one of the reasons that why the industries are not really improving to the extent they should improve, or they should adopt new technologies. In areas where there has been restriction and there is compulsion, definitely we have done much better, like your atomic energy, space, and even to some extent actually in the defense sector, we have also done very well. They are all because of actually restriction, and we didn't have the opportunity to borrow this technology. But whereas in all other cases, where we are neither actually focused on developing world-class product in our design or manufacturing them actually efficiently at low cost, because whatever that we do here, we can sell. There is just a customer. Whereas that is not actually the case for the developed world. They have to really look for customers. This is just my observation. I may be wrong.
So you're right that there is a large potential customer base, but my impression is that there is not a lot of disposable income in all of the customer base. So in other words, many people are focused on food, shelter, that sort of thing, rather than being able to buy consumer products. But again, that's my impression. I believe that India needs to do basic research to become self-sufficient. And then in that case, if they do basic research, then they will be able to develop products that are globally interesting and exportable. So you're right that export is an important activity. So that's what I say. Do you want to say something?
I think the key message here is that there needs to be a transformation in the way people think and do things. Manufacturing has provided a lot of jobs for people, and that's necessary. The change needs to go from make in India to design and make in India. Design involves intellectual activity. In manufacturing, you can import the technology and you can make it. But in design, it's creative. You have to do something new. And that is where I think India needs to be headed. Utilizing the brain power of 1.3 billion people. So if you think in terms of North America, United States, there are 330 million people. In India, there are 1.3 billion people. And if we say 5% of the people in North America, in the United States, are geniuses, and we take 5% of the people in India are geniuses, the number of people who are geniuses in India is far higher. What opportunity are you going to provide for them to do nation building? And nation building is not just getting technology from elsewhere and then implementing. Nation building means developing the intellectual horsepower, the capability of its population as well. And you can take a look at countries like Singapore, like Korea, who have invested heavily in basic research, and you can see what sort of industrial giants they have become. So that's my comment.
Yes,
Madhu,
Chakravarti, you want to say something?
Yes. I think I totally agree with Janet when she says that the universities, the education institutions should focus mostly on basic research and create educated and skilled workforce. While the government laboratories that in which you have invested a lot, they should be handled the
She's from
university.
University of Oklahoma. She's giving a talk on design and to manufacturing. How it should be done. You know the total number of attendees?
Can I continue?
Yes, please.
Yes, sir.
Ah. So actually, there should be some policy. The government should stress that the laboratories, government laboratories should focus mostly on translational research. And the same should be upscaled in the industry. One of my observations that in India, there are many industries, but I would not like to call up many of them industries. Many of them are basically traders. An industry means which have facilities, provisions for research. Translate from basic research, take up from research from laboratories and education institutions, and then do research on an industrial scale. A couple of industries do that. Tata's has been doing that for quite some time, but many, the SAIL has been doing that for quite some time. That is not happening. And as Professor Acharya has rightly said, most of the industries, they find a market within India, so they don't think it's necessary to upgrade. Because the challenge is make in India. Then after you make in India, what do you do with the product? The product has to be sold outside. If you cannot export it, then there is no point. India's export has to increase. I'm sure India has done very well, particularly in the textile industries. They have been doing well for quite some time, but not in all industries. And India is also facing problem of dumping from other industries. So that's a huge problem. So where do you start from? I think if we take the suggestion of Janet, we may, from INA who are organizing lectures, we may suggest to the government of India, that they should form a policy. They should not, I have seen in this country most of the time they put a lot of emphasis on IITs that you should do industrial research. Or IITs do not have the infrastructure to do industrial research. I've been doing research in metallurgy. I could make 5 kg of metal, but SAIL can make 400 kg of metal. There's a big difference between what you do in a laboratory in a small scale and what you do in the industry. As the scale goes up, there are lots of other problems that are coming, which the industries can do. So the government should still, the government has set up IITs, government has set up IISc and many universities. They should focus and concentrate, and the funding should be there for basic research in universities. While the government laboratories should be told that you do mostly translational research. Do a hand-holding with the universities, pick up problems from a university if they do a basic research, scale it up, and then they should do the hand-holding with the industry, or it can be industrial. You can go for industrialization, you can go for commercialization. And this is what I wanted to suggest. Thank you very much.
It sounds reasonable, like a good idea, but this has to be accomplished.
Yes.
So,
Sundaran sir, please. Sundaran sir, kindly unmute and ask your question. You have raised the hand.
Dr. Sundar,
Am I audible?
I can hear you, yes. I
Yeah.
think
Yes.
Sundaran sir has raised the hand, but I think he's not able to.
He has not.
Okay, any other questions from esteemed members?
Please actually unmute. Sundaram sir. There is some problem.
Jaidev Bala sir, would you like to ask question?
Yes, sir. Yes,
sir,
madam. I'm audible?
Yes, sir, you are
Yes,
audible.
See, there is a very good scope for what is this called? Design digital twin. Digital twin. Can you throw some light how we can do work on digital twin? That is gaining popularity because of this IoT. IoT. You want to know what we can do on digital twin?
All
That
right.
is
So
very interesting. I see in the technology sphere.
let me answer that question. The whole idea of a digital twin has been hyped. What is a digital twin? A great example of a digital twin is the airplane simulator, where you put a pilot into the simulator and that pilot then learns how to fly the plane without actually getting into a plane. That is the idea of a digital twin. What has happened in the literature is that anything and everything that people are doing, now they call it a digital twin. That is not true. So it's a lot of hype. It does not really support what is needed. And so I would caution you that when you read about this thing, think about what this digital twin actually means. And it means that you have in a computer, you have recreated the physical world. In a computer, you have recreated the physical world. It is not just coming along and saying, oh, I did some simulation, therefore it's a digital twin. So I would caution you about that. And it's hyped and people use it, but in my opinion, they misuse that phrase digital twin. What is important is the digital thread. What does the digital thread do? In Industry 4.0, what happens in the digital thread is information is passed from one entity to the next entity to the next entity. And ensuring that that digital thread is appropriate, connected, has value, each thread adds value to the next thing, makes a lot of sense. So if people talked about creating resilient digital threads, I would say yes. But in terms of digital twins, it's a far cry. So for example, Madhusudan mentioned about coming up with 5 kilograms of material. That is in his laboratory. Tata Steel comes up with 400 tons of steel in its production line. Now, if we were able to model what Tata Steel does and then control that process, then that is a digital twin. But if we can't do that, that is not a digital twin. And so I think we have to be very careful about how we use this phrase digital.
So let me add a little bit to that. There are perhaps strategic ways of going about accomplishing Industry 4.0, Design Engineering 4.0. And you need to take a look at where India is currently and build on that instead of jumping to something that is far more advanced, but not in keeping with everything else that is available in India. So you have to be really careful. Farokh is right about what people think a digital twin is, but how many digital twins are needed at the state that India is in now and in which industries? So it's a very important thing.
Thank you, ma'am. Now, I would like Sundaran sir to ask, please.
Sundaram sir, will you
Unmute.
can you unmute? Sundaram, can you unmute and ask your question? You have raised hand.
Dr. Sundaram, you are muted.
You please unmute. Acha. Yes, Harish Saab, you want to say something? Harish Wadhwa?
Yeah. My question is about what kind of design and research dynamics are there in different industry, right? I'll take two examples. Automobile industry, which is much more mature in India, versus electronic manufacturing industry, which is gone to the very, very basic stages of it. We are trying to revive our electronic industry. In both these scenarios, two extreme situations, right? How do you see the mix of academic research and business houses contributing to research? How should it work? How it's working in US compared to India, and what can be done to improve it?
So you've asked a difficult question. I think that you need to do things differently, obviously, for the different situations you've got. I believe that there are situations where it is possible to leapfrog, industries from one stage to another. For instance, you can think about the way the digital, these telephones worked and were brought into India. So basic research can help you identify opportunities such as those. But again, you have to take a look at different industries separately. Some industries, for instance, t-shirt manufacturing may not be suitable for Industry 4.0 at all. And you may wish to focus on those things where you will get some return on your investment.
So on the chat box, Sundaran sir has given the question. Dear Professor, thank you for the excellent lecture. Incidentally, Dr. Kaswat is not a politician. He is full-blown engineer. He have worked together with Dr. Kalam. Thank you, sir, for information. Okay, no problem. And we are having Karishma Koka. She has written a gratitude for today's splendid lecture. How is Industry 4.0 primed for disruption of technology in the light of reduced normal competition together with the high cost of Industry 4.0?
I'm sorry.
I'm not finding any more questions. If anybody, please.
I have one small observation. So if we have really hunger in our belly, then only we can try and do basic research, develop new product, new design. Now, if you take actually one small statistics, that our per capita export is merely $2.240. Similar thing for China with similar population is $2,400. And when it comes to US, it is something like $5,400. That means actually we do not have, arts to export or capability to export. And even if our exports are mostly related to raw materials or semi-finished products, and some of those things are also related to wherever actually we had traditionally strength. So for example, our handloom, handicraft, jewelry, we had actually enough of expertise and strength in this area. And there also export is good. But when it comes to the other things, we are exporting ores. Even in chemicals, bulk chemical export is pretty high from India. But whereas fine chemical, we are not able to produce. for example, all our APIs in pharma industry, where most of them are being imported from China. And what we are doing here, we are having some tablet making machines, and those tablets actually we are making and we are exporting to some other countries. That is actually not the thing that that will really drive research in our country. The driver from research actually will come from the requirement of the country and requirement of actually the industry. And those people must have the hunger to have this basic research. You see, the countries which I have just quoted, like China, which was really pretty bad, almost at same level, something like 30, 40 years back. Today, they have leapfrogged and their research has also gone up because they made it a point actually that how the products, whatever they make, how they could be exported to different countries. The similar thing has happened in other places like, let us say, Germany or US or Korea, Japan. A lot of research actually is taking place in those things because their job is, their focus is actually how to make something and export to some other countries and thereby create things. I believe actually that is one thing which you have to really think of very seriously so that we create such an opportunity that we are where in certain areas at least we should be the exporter of actually product rather than simply consumer of the product. This is just one of my observations.
So I think that you have made the case that basic research is needed to add value to the products.
Okay, madam, can we, Renu,
Yes,
madam,
we can.
can we close it?
Yes, sir. We can close now.
Please propose a vote of thanks.
Thank you. Thank you, sir. It's my honor to propose a vote of thanks on this occasion. Thank you, Professor Janet, for giving a wonderful lecture. This webinar was very interactive and we learned many things like how the industry 4.0 and how we can have a merit-based research, especially led by experts in India especially. And observation about Indian research structure was very, very interesting. And the discussion after the presentation was the outcome, which I learned from it, that the way we are heading, like we have to work towards more make in India, not only make in India, design and make in India. And on behalf of INA, on behalf of SOA, and behalf of IMT Bhubaneswar, I extend a heartfelt thank to esteemed member and the presenter, Madam Janet, for giving their time, valuable time, for this wonderful presentation. Thank you, ma'am. Thank you all the esteemed members for being so interactive and positive in discussion. Thank you.
Thank you.
Madam Janet, actually I have got one small thing. Can we share your slides?
Certainly, I'll send them to you.
With your permission. If you permit, then it can be shared.
Please,
I'll
please,
send them to you.
share your slides, please.
So,
Okay.
thank you again for the invitation to talk to you. I believe the design engineering portfolio is extremely important. Research is going to be very good. So thank you again for the invitation.
Okay.
Thank you and namaste all. Thank you. Officially, we are ending this meeting, but the process will continue and we stay connected.
Thank you so much. Madam, actually there is a small memento from our side. That memento, along with the memento which was meant for Professor Arun, we will actually hand it over to you. Not actually. When you come in December, that time we'll get in hand.
Okay.
Otherwise, actually, the postage cost may be more than the memento itself.
Thank you.
Good to see you, Janet.
Good to see you again.
Bye.
So very
Good to see you,
good.
Farooq.
It was
Thank
such
you.
a pleasure. For your information,
Thank you
I
so
have
much.
been actually their guest in their house.
Yeah, I had been to Oklahoma as well in his
Yes,
house.
yes.
Yes.
But I had been to Atlanta. I'd been to, I had been, he was my host in Atlanta also,
Yes.
number of times.
There was a flood, I think.
There was a
There
flood.
was a flood, yes, I remember. There was a flood. Your basement got flooded when I was there. Mhm.
Karishma, see you. Such a pleasure to see you.
Yeah.
You attended the other meeting also.
Okay. Bye, folks.
Bye.
Have a
Bye.
nice day.
Bye, Farooq. Bye, Janet. Bye.
Bye.
Bye, Prasacharya. Bye, bye.